He knows a lot about the science stuff. Professor Dave explains.
Hey guys, Professor Luigi here. Let's talk about the general theory of column chromatography.
Chromatography, a technique in which the components of a mixture are separated based on differences in the rates at which they are carried through by stationary phase and mobile phase. The first photo is a mixture of components that will undergo by chromatography technique that we desired to obtain a single component. Stationary phase is a phase that is fixed in place either in column or on a planar surface. The picture here on left side is an example of stationary phase in column chromatography, and the other one is an example of stationary phase on a planar surface. Mobile phase is a phase that moves through the stationary phase, carrying with it the analyte. As you can see, the picture here is an example of mobile phase in paper chromatography. The second one is the example of mobile phase in column chromatography. So what is column chromatography? The basic principle involved in column chromatography is to adsorb solutes of the solution with the help of a stationary phase and further separating the mixture into discrete components. Column chromatography is a separation technique in which components of a mixture is separated by using a glass column pack with a stationary phase and the liquid mobile phase flowing continuously through the column. The forms of column chromatography: liquid chromatography and gas chromatography. The most widely used forms of column chromatography are absorption chromatography, partition chromatography, ion exchange chromatography, gel chromatography, affinity chromatography. The two main thing in instrumentation of column chromatography, mobile phase is the liquid state, stationary phase, the solid state. Column chromatography consists of the following components: stationary phase, the column, the mobile phase, the detector, and the collector. In preparation of column, the column mostly made of glass tube pack with stationary phase, either silica or alumina. A glass wall or a cotton is placed at the bottom of the column before packing the stationary phase. These are the two types of preparing the column. First is dry packing, or what we called dry filling. Fine dry powder is filled in the column and then solvent is allowed to flow through the column. The second one is the wet packing. The slurry of adsorbent with the mobile is prepared and is poured into the column. Stationary phase should be filled uniformly without any air bubbles. Introduction of sample. The sample mixture is dissolved in minimum quantity of the mobile phase. The entire sample is introduced into the column at once and get adsorbed on the top portion of the column. The individual sample can be separated. Elution. By elution, the individual components are separated out from the column. These are the two types of elution: the isocratic elution and the gradient elution. Isocratic elution is the solvent of same polarity is used throughout the process of separation. In the whole process of your separation, you only use single solvent. For example of it is chloroform. The gradient elution, solvents of gradually increased polarity or increased elution strength are used during the process of separation. For example, you initially use benzene, then you use the chloroform, then you use the ethyl acetate, and then back to chloroform. So in short, in gradient elution, you use three or more solvent, while in isocratic elution, you only use one. The detection of components. If the compounds separated in a column chromatography procedure are colored, the progress of the separation can simply be monitored visually. And if the compounds to be isolated from column chromatography are colorless, in this case, small fractions of the eluent are collected sequentially in labeled tubes, and the composition of each fraction is analyzed by TLC, affecting column efficiency. First is the dimension of the column. The width, ratio, height, and length are significant factors, increasing the column length, resulting in better separation. The other one is the particle size of the adsorbent. This is also a significant factor in the improved separation, and if the size of the particle decreases, the separation is improved. Nature of solvent. The solvent in column chromatography is used with less viscosity, as the viscosity can influence the flow rate of the solvent system, and which affects the separation of the component. Another one is the temperature of the column. It is also a vital factor in chromatographic separation because some chromatographic columns are damaged at higher temperatures, and proteins can also be degraded at high temperatures. Pressure. Pressure is also the factors affecting column efficiency. High pressure in the column and low pressure under the column, it enhances the efficiency of separation. Column chromatography is one of the most useful methods for the separation and purification of both solids and liquids. It applies of separation of mixture of compounds, the removal of impurities or purification process, the isolation of active inconstituents, isolation of metabolites from biological fluids, estimation of drugs and formulation or crude extracts. The advantages. Any type of mixture can be separated by column chromatography, and any quantity of mixture can also be separated. Wider choice of mobile phase. In preparative type, the sample can be separated and reused. Automation is possible. These are the advantages of column chromatography. How about the limitations? It is also time-consuming method. More amount of solvents are required, which may be expensive, and automation makes the technique more complicated and costly. So that's it. Thank you so much and have a good day.